P2, right? So we're going to be a little more careful. So, you know, P2 is actually more in this direction, right? It's not a perpendicular projection. We're not doing orthogonal projection. We're doing projections. Well, they are orthogonal within the eigenvector basis. But the eigenvector basis is sort of space. Okay? And we're doing it in the original space. So we have this, right? So here we've got C1, P1 all the time. Okay? Now here we've got C2, P2. C1, P1 is static, which you ought to understand in terms of what we just said. Okay? C2, P2 is this. But now we're going to get this, which I didn't really label up here. Just to give myself a little more space, I can at least label this one. .7 C2 P2, right? And then that's, you know, this little mark here is just a 70% mark, okay? And you can get your video out and measure it and see that I'm good to within a tiny fraction of a percent. Okay, well, don't believe it. Wrong color, wrong color. I want to use a different color that I haven't used, so I'm going to use this one, okay? So, well, the next one's going to go 70% of this length. It's going to be like here, and then 70% of that's going to be like here, and 70% of that's going to be like here, 70% of that's going to be like here. They're going to get closer and closer together because you're doing 70% of something smaller and smaller, so you're going to lose 30% of something that's smaller and smaller, so this spacing is going to get smaller. So you now have this sequence of vectors it gets denser and denser as you get toward this, okay? And your general vector, if I can find another color, I've got yellow. You see little tiny bits of yellow. So I'll use a little tiny bit of yellow. So in general, you have this yellow vector, and yellow doesn't look that much different than green, but this thing is and you might not be able to see that because of the angle you're sitting at. Okay? Your nth vector, your nth transition, is going to give you this one. Okay? It's a to the n v naught. Okay?
Thank you.
And that's this. And that kind of brings it full circle and gives you a little bit of a clue as to some of the really neat things we can do with eigenvectors. Okay? Now there are some actually more complex examples in the last section of Chapter 7. We're not going to have time to do those thoroughly, but I wanted to do at least this one. And it wouldn't hurt you to read that because it could be useful to you. but not for a while, and you're going to forget it before then. So just be sure you learn it well enough now that it comes back to you, because you're not going to use it again until next, winter after next. It's going to be over a year and 2 months, roughly, 3 months maybe, before you get to the application they use here for systems of differential equations. And you're not in a position, taking Calculus 1 right now, to understand a systems of differential equations, although you're welcome to sit in on my class in February when we do it. Okay? But you'll find it to be relatively easy if you understand how to do eigenvalues and stuff. And my experience is, in that course, that people come in